Hello students, how are you all? Hope all of you are well. Today we are going to discuss class 9 science chapter number 8 motion. Our main topic is uniform circular motion. In the previous video I had explained you about the equations of motion like v minus u is equal to at or v minus u by t is equal to a. Acceleration formula, final velocity minus initial velocity upon time taken. After then distance formula I had explained you s is equal to ut plus half at square, and after then I had explained you b square minus u square is equal to 2as. Today first of all let us describe something about the uniform circular motion. The word uniform means just like equal interval in equal distance travel in equal interval of time is called uniform motion. Equal distance traveled in equal interval of time. Now question is what about the circular? How this circle, as for example just suppose, have you ever seen a hexagonal? First of all just suppose this is triangular, right? This is rectangle, and now I am talking about the pentagon, means 5 equal sides. Have you seen this? And now I am talking about a hexagonal, 6 equal sides. How many? 6 equal sides. Now I am talking about octagonal, 8 equal sides. See, 8 equal sides. This is called octagon. So these are the shapes you may have studied in mathematics: triangle, rectangle, pentagonal, hexagonal, octagonal. Now you can see equal distance, equal interval of time. If you just name these 8 points and you just suppose that all the distance are same, A, B, C, D, E, F, G, H. See 1, 2, 3, 4, 5, 6, 7, 8. 8 equal intervals, 1 meter. Just suppose this is also 1 meter, this is also 1 meter, this is also 1, this is also 1. Equal distance at equal interval of time. Equal distance at equal interval of time. When an object travels equal distance at equal interval of time is called uniform motion. And when an object travels equal distance in equal distance at not in equal interval of time, so that is non-uniform motion. But today's our topic is circular, and in circular also uniform circular motion. So in the NCERT textbook it is already cleared about this topic. In the NCERT it's written that when the velocity of an object changes, we say the object is accelerating. Definitely when the object it will change, the velocity will be changed. So what will happen? We say acceleration, v minus u upon t, as the velocity is changing. So the change in the velocity could be due to the change in its magnitude or the direction of the motion, both. Can you think an example when an object does not change its magnitude of velocity, but only the direction has changed? Are you understanding? It is not changing the magnitude, but only direction they are changing. I have informed you about the vector and scalar quantity, in which both the things are there. Direction and magnitude both. If anybody asks you what is this magnitude, then I have informed you the covered distance. In any of the topic, the distance covered. Here the distance has been changing. A to B was this line, B to is this side, C to D here, D to E, E to F, F to G, G to H, H to A. So you can see here the directions are being changed, right? So what I want to say you, can you think an example when an object does not change its magnitude? A to B, the distance is also same, B to C means time is also same, but the distance is being, direction is being changed. Can you think an example when an object does not change its magnitude? Magnitude it is not changing, but only what it's changing? It is changing the direction. So let us consider an example of the motion of a body along a closed path. You can see in this figure, especially I am talking about this octagonal. And athletes travels in the rectangle. You can see here ABCD, this is the rectangular path, ABCD. This is a rectangular path. When they travel in the different direction, you can see here. And after, let us assume the athletes runs uniform speed on a straight path AB, BC, CD and DA of the track. In order to keep himself on track, he quickly changes speed at the corner how many times will he athlete has to change its direction of the motion while he complete one round. It is clear that to move a rectangular track, once he has to change his direction of the motion 4 times. See here, if an athlete starts running from here, and as how many times he has to change the direction? First direction is this, second this, third this, and fourth is this. So 4 times he has to change the direction in a rectangular square box, right? Now suppose instead of a rectangular track, the athlete is running along a hexagonal, this hexagonal path A, B, C, D, E, F. Now how many times he will change the direction? First time, second time, third time, fourth time, fifth time, and sixth time. In the hexagonal, how many times he is changing the direction? As you can see, the athletes have to change 6 times while he completes one round. What if the track is not a hexagonal but a regular octagonal? So octagonal means 8 sides. So how many times it will change? It is observed that as the number of sides of the track increases, the athletes has to take turns more and more often. What would happen to the shape of the track as we go increasing number of sides? If you do this, you will notice the shape of the track approach to the shape of a circle, and the length of each side will decrease as a point, and the athletes move a velocity of a constant magnitude according to the circular path. Now the change, his velocity is due to the change of the direction motion. The motion of the athletes moving along a circular path is therefore the example of accelerated motion. Now we can say the circumference of a circle of the radius r is given as 2 pi r, and the athletes take t times, so v is equal to 2 pi r by t. Now what I want to say you is, just suppose here, this was octagon, this was rectangle, this is hexagon, this is pentagon, this is octagon. Now more than 8, 12 sides, slowly you will observe a shape of circle, right? Which shape? Circle. Now here you can see how when there is no change, means already it is changing in all the direction, right? It's a circle direction. As the athletes, here it was changing 8 times direction in the octagonal, 6 times in the hexagonal, 4 times in a rectangle, 5 times in a pentagonal, 3 times in a triangle. Now if I ask you what will be the speed of here, here you can just understand about the circle center, it's a radius, and the circumference whole is 2 pi r. All of us know according to the maths, circumference is c is equal to 2 pi r. So how many time has taken to cover this whole distance? So v is equal to 2 pi r upon time taken, right? Can we write v is equal to 2 pi r by t? So we know the circumference of the circle is 2 pi r, and if athletes had completed one round in t seconds, so v is equal to 2 pi r by t. Now when an object moves in a circular path with a uniform speed, it is called uniform circular motion. When this athlete is moving with the same speed into all the direction here in the circle, so that type of circular motion will be called uniform circular motion. If anyone will ask you what is circular motion, right? What is circular motion? Then you have to just give an answer. When an object moves in a circular path, when an object moves in a circular path with uniform speed, when an object moves in a circular path in a uniform speed, it is called, what is called? Uniform circular motion. It is called uniform circular motion. If you carefully note, on being released, the stone moves along the straight line tangential to the circular path. This is because once the stone is released, it is continued to move along the direction it has been moving towards the instant. This shows that when the stone was moving along the circular path, when an athlete throws a hammer on a discus on the sports meet, he holds the hammer on the discus on his or her hand and gives a circular motion by rotating his or her own body. Once released in the desired direction, the hammer or discus moves in the direction in which it was moving at the time it was released. Just like the piece of stone in the activity described above, there are many more familiar examples of objects moving under the circular motions, such as the motion of the moon and the earth, satellite of the circular orbit around the earth, and the cyclist of the circular track on the constant speed and so on. See, first of all, this Uniform circular motion is described specially according to the sports only. As already I have told you about the 100-meter race, 200 race, it is a circular motion race. After the circular motion, you may have seen the disc throw, right? We are specially playing in the schools when our annual sports camp. We have to throw the disc. How much meter you have throwing the disc? You will see the disc is also moving round, right? Uniform motion. Secondly, if I talk about, if we are having a stone, just suppose this is a stone, I will tie this stone with a thread and I will rotate. It will move into the circle. The radius will be fixed, r will be fixed, as the circumference will be 2 pi r, and how many seconds I am completing one oscillation, two oscillations, three oscillations. There are many more examples about the uniform circular motion. But remember, if anyone will ask you what is uniform circular motion, then what you have to just describe about when an object moves in a circular path. When an object moves in a circular path. What do you have to say? When an object moves in a circular path with uniform speed. With uniform speed. When an object moves in a circular path with uniform speed, then that object motion will be known as uniform circular motion. When an object moves in a circular path with uniform speed, its motion is called uniform circular motion. Today we are going to solve one more numerical related that, and after them I hope we have completed our motion chapter of class 9, chapter number 8. After then we will study the next chapter, but before completing this chapter, let us solve one or two numericals related that, so we will be able to understand, right? An object starting here, there is one more numerical in your science textbook only. You can solve these numericals also as it is given. A car accelerated uniformly from 18 km per hour to 36 km per hour in 5 seconds. Calculate the acceleration and the distance covered by the car in that time. So here you can go through. It is 8.6, question number 8.6. In a textbook it's already given. So after that you can solve that numerical. You have to find all that three equations of motion. As already I have informed you about the acceleration, I have informed you about the distance, and v square minus u square is equal to 2af. So v minus u upon t is equal to a. Second was s is equal to ut plus half at square, and third was v square minus u square is equal to 2as. So let's start with this numerical. A car has been accelerated in the uniformly from 18 km per hour to 36 km per hour in 5 seconds. 18 km per hour. U is 18 km per hour. V is 36 km per hour. S is equal to 5 seconds. Right? After getting the knowledge about this, calculate the acceleration. What do you have to calculate? A. You have to calculate the value of A. And second is distance covered by the car. And second, you have to cover the distance. Distance means S. You have to calculate the value of S, right? So S is equal to ut plus half at square. So first of all, what you will do? You will convert the distance into meter per second, right? What we have to do? We have to convert the distance into meter. This is your first question, and this is your second question. Can you tell me what will be the value of U? U will be 18 km per hour. Means 18 into 1000 upon 60 into 60. 0, 0, 0, 0. Cancel. 6 3 are 18, 3 2 are 6, 2 5 are 10. So it's equal to 5 meter per second. U. V is equal to 36 into 1000 upon 60 into 60. Right? 0, 0, 0, 0 cancel. 6 6 are 36. So it will be 10 meter per second. Now you can easily calculate what is the value of A. A is equal to V minus U upon T. V value is 10 minus 5 upon 5. 5 by 5. So what is the SI unit of acceleration? Can you tell me? Acceleration SI unit is meter per second square. So here acceleration is 1 meter per second square. Got it? So this was the answer number 1. Now the second one. S is equal to ut plus half at square. Ut plus half at square. So already we have calculated the value of A. So U is 5 meter per second. 5 into 5 plus half into 1 into 5 into 5, right? So 5 5s are 25 plus 25 upon 2. LCM 2, 50 plus 25 is equal to 75 upon 2 is equal to 3 to the 6, 7 to the 40. 37.5 meter. What will be the distance? 37.5 meter, right? So this was our question related to the equations of motion. I hope all of you are understanding. If you are having any doubt related of any numericals of this chapter, then please inform. In the next video, I will describe more and more numericals related to this chapter. That's all for today. Thank you very much. Don't forget to like and subscribe. Share this video with your friend so they can also be benefited. Thank you very much.